So our next speaker is working at the intersection of AR and AI, which is super interesting. This is one of the few investments that I ever committed to literally in the first meeting. When Chen showed me the demo of what they're doing, we committed to investing on the spot. So I think it's a really, really interesting company. So please welcome Chen-Ping Yu.
Thank you, Rob. Hello. Thank you, Rob, for the intro. Hi, everyone. My name is Chen-Ping Yu, co-founder, CEO of Fire. My background is in computer vision, machine learning research with focus of efficient computer vision. That means running it really fast and really efficient and really at low power devices. And our startup, Fire, is working on AR navigation, as Rob mentioned, on the phone. So it's an app that can download. And that also means it has to run really efficient computer vision AI at the edge in real time. And therefore, today, my talk is going to be about the general idea of computer vision running at the edge and the challenges and opportunities that are associated with it. OK, so that's our title slide. So first, let's talk about what computer vision is. It's a technology, it's a field that enables computers to see and understand the world, much like, well, they try to be like human vision, to identify different things, to perform different visual understanding and perform associated tasks. And some of the popular tasks includes classification, as in potted plants and dogs, potted plants, and also detecting different objects, dog, bicycle, trucks in the second image to the right, segmentation, partitioning pixels into semantically similar categories from the image or video frame. And there's also tracking, pose estimation, depth estimation, 3D computer vision, and a lot more use cases there. And what really made a difference, as everybody's already well aware, is the invention or the recent popularity of deep learning, the breakthroughs that happened in 2012. And before that, computer vision has been largely statistical machine learning based, and the improvement has been really slowing down. Around 2010-ish, deep learning really broke through that barrier and got us where we are now, and everyone is interested in AI, and that's what's made computer vision possible in all sorts of applications. So some of those graphs maybe you've seen before, but these are the accuracy improvements over the years since around 2010, right before deep learning and afterwards. So the left graph is ImageNet classification accuracy of the 1,000 categories of images. Objects. Starting before 2012, things are kind of low in terms of accuracy. All of a sudden, everything jumps up afterwards, and in recent years, it's over 96% accurate compared to human accuracy, which is at 95%. On the right-hand side is object detection accuracy, also a big jump after deep learning has been really hitting the shelves and breaking those old methods in terms of top-line performances. If we look at it from another angle, so I looked up on Crunchbase, if you filter by funding amount of over $1 million, companies that were founded before and after 2012. Before 2012, 68 companies in computer vision, autonomous vehicle also a smaller number, drones, these are all computer vision related companies, and there's a sudden surge after deep learning has been popular. So that's really good, but there's also an important aspect of computer vision, which is for it to happen in real time. Real time means live immediate visual perception, and you want it real time because you want predictions to happen and work for you right away. And usually that means at least 30 frames per second of processing. It can be slower depending on use case. If you're tracking like a slower moving object, then you don't have to hit 30 frames per second. But in general, that's the case. And the use case includes robotics, retail, security, augmented reality, which I'll focus about later on, and automotive, such as self-driving cars. So some interesting GIFs that I kind of compiled to show that real time is important. So for some situations, such as healthcare, maybe you don't need real time because, yeah, for AI to detect brain tumors and lung tumors, these are great. You don't want to wait days to know, but you also don't need 30 frames per second. However, in these cases, such as object detection for self-driving cars, AR games of recognizing your hand gesture, detecting driver fatigue, and alerting the driver, and also cashier's checkout to detect person's pose and the kind of object they picked up and tracking it. These all have to happen in real time. And so real time is really important for computer vision. So that's all good with deep learning-based computer vision in real time. However, there's also a lot of challenges, as a lot of people have already mentioned. First, deep learning requires a lot of data. And secondly, to make inference, to predict, typically that's done on high-end desktop GPUs. And that's why most of the use case for deep learning computer vision today is happening in the cloud, or it's also for enterprise-facing use cases, because it's expensive to run deep learning. Expensive in terms of hardware, and also about setup. And it's not exactly mobile, because as a consumer, as a person, if you want to bring AI with you, you can't carry that as a backpack and walk around with it. Therefore, these are the challenges of deep learning that needs to be overcome before we can actually deploy that to even more people, such as consumer-facing related use cases. And that's where I talk about at the edge is really important, because nowadays it's all about enterprise and cloud. But there's more than 4 billion smartphones in the world people are using. And that consumer space has not really been explored today. And that can only work if you're able to deploy real-time deep learning computer vision at the edge. And also there's other things such as drones, tablets, low-powered mobile devices. Some additional benefits of why we want real-time CV at the edge instead of on the cloud with different use cases, but hopefully these benefits will show you that it's important to run at the edge. One is speed and reliability. So because you're not transmitting data between your end device to the cloud anymore, and therefore you're not delayed by any kind of transmission delay. And also you don't need to care about the loss of signal. Data security integrity. You're no longer connected with your cloud server, and therefore you're unplugged from the grid. And so a lot of people, they're kind of concerned about self-driving cars being hacked. If you're running things at the edge, you don't have that issue anymore. You're not connected. People can't hack into it. Also, scalability and cost. If you're building your cloud infrastructure, as you grow in business size, you have to continue to expand that hardware. And that's expensive and that's tough. But if you're running things on people's end devices, you have more customers, they already have the computational device available. Your growth in terms of your hardware requirement is limited compared to what they already have to help you out with. And finally, it's consumer friendly, because that allows you to get to use cases where that can happen directly on the phone instead of more of an enterprise-facing use case today. But how do we enable deep learning-based computer vision to run real-time on a low-cost device such as smartphones? So that includes the following. It's really from the more engineering perspective. One thing is you can compress your neural network model, for example, using these well-known compression techniques such as knowledge distillation to train a larger network and then have a smaller network that can run on your device to learn from that larger network. Architectural search, whether it's automated or you search a better architecture that's smaller and more efficient. Separable convolution means really separating high-dimensional convolution that's happening in every neural network today into lower-dimensional convolution, such as 1D or depth-wise separable, such as mobile nets architecture. Quantization, meaning instead of running 32-bit numbers that constructs your neural network's millions of weights, you maybe lower that to 16-bit or 8-bit or even binary, and that can also save in terms of making your model smaller and faster. Another important thing is nowadays more and more chip makers are coming out with chips that already have dedicated neural network processing units on it. Some example is Huawei's Kirin chip has a neural processing unit. Qualcomm's Snapdragon also has a dedicated silicon for neural network processing. Apple's A11, A12 Bionic chips has something called Apple Neural Engine to help dedicate processing of neural networks. The issue here is that in Android phones, where you have those later processors. They have SDK available, but so many different vendors making different kind of hardware. So it's really difficult for you to test your solution on all those different phones. And on the Apple part, they only have Apple as making iPhones, but they don't have SDK available for you to directly work with their neural processing engine on their chip. So those are also technical drawbacks, which hopefully Apple will release new SDKs to help that. Okay, so let's dive into use case of what we're working on in terms of how real-time computer vision on the edge helps us. So our use case is navigation. Navigation, as in GPS navigation, there's more than 2 billion active users regularly use GPS navigation around the world all the time. I'm sure most of you in the audience use navigation when you drive. That's more than 77% of all smartphone users and over 90% of people that drive. It's a huge market. Even if you just get 1% of the market, there's a huge amount of people. And therefore, GPS navigation is a must-have, not a nice-to-have. Great place to get into. However, current GPS still uses 2D maps such as lines and arrows to show you directions. So this is a real screenshot I took when I was in Boston. I was at that arrow. I was looking at where I was supposed to go. Google Map told me to take a certain blue route. I looked up in front of me. I had no idea what that means out of 10 different roads in front of me. That happened to me all the time in Boston and also in San Francisco. So I feel like if my phone's already mounted, the camera's already facing forward, why can't somebody just show me the live view of what's in front of us and just overlay where I need to go on that so I know exactly where to go instead of trying to read the map and figure my way out in a split second where I'm driving 50 miles per hour. And that's what we're aiming to do, is AR navigation. So we show you your directions by directly overlaying that onto the road.
Continue
so that
along Pacific Boulevard in 400 feet. Turn right on Clark Drive.
So that all it takes is a quick glance.
Exit right
Instead of
towards
map
Main
reading.
Street.
And you'll never miss
In
another turn.
400 feet,
It makes
turn
finding
left onto
exits
Main Street.
and lane merges so much easier. And also safety warnings in case you're not paying attention. So we beep and make sure you're okay.
In 50 feet, turn right on Smith Street.
And so the idea is that you're not staring at it. You're only glancing at it when you need directions. But there's also no learning curve because you're
In
not
50
reading a map
feet,
anymore.
your destination ahead. Home.
So we found this use case for AR and AI altogether because AR, even though that's not the topic today, but people think that's a hype because smartphone is not great for AR. But hopefully this shows that AR with navigation on a smartphone, which you already use for navigation, is a readily available use case for everyone today. But in order to build that, we need on-device computer vision to understand the road in front of you. So here are some examples of our screen recordings of our iPhone technology and AI. Object detection, which everyone has seen all the time, but running directly on the phone alongside real-time semantic segmentation to tell us where are drivable roads, where are the different things in front of you, and also real-time lane instance segmentation. So not only just lanes, but also different instances of lanes. So we know how many lanes there are, which lane you're in, and all of those combined with other technology, of course, allows us to build AR navigation running directly on device to help people to drive better. That concludes my talk. Thank you.
All right, any questions for Chen Ping? Anybody have one?
So we're aiming at, by the end of the year, that if you have an iPhone, you can just download. It's going to be free for download. Everything's going to be free. Yeah.
And describe what the first product is. What's the one product?
Right, so first product is AR navigation. So you can enter your destination, and we show you the navigation direction overlays in AR. We're not going to ship other features such as points of interest search, but that's going to be coming later afterwards. We also want to add in dashcam recording feature. For example, it records up to 30 minutes of footage, so you can use for insurance purpose, safety warning, things like that. That'll come later. 2.0 product is going to be with safety warning, dashcam recording, and voice command. Hopefully, that can be added in. 3.0, or our long-term goal, is that we want to get in. We believe AR glasses will be the next smartphone. We believe in AR as the next future technology, so we can interact with the world. But building infrastructure and software needed for AR. It's a huge undertaking. So this is our first step in collecting data from our users, because now we have access to our users' cameras. So we can build 3D maps from crowdsourced data. We can build AR cloud, digitize the world with our users' data. Yeah.
Which AR glasses are you working with now in data?
None, because none of them are ready. they're all very chunky, and right now they're all focused on enterprise-facing applications. Yeah.
10 years, rank the AR glass manufacturers by market.
You're really good at questions. Based on what companies are still around today, I know that HoloLens is doing pretty well, but they're Microsoft, they're enterprise-facing. Magic Leap, they have a product that's pretty good. Intel is actually making their own AR glasses. Facebook just announced their own AR glasses plan, and Amazon, I think, is also making theirs. Apple is also announcing something about their AR glasses. So I think this is a very interesting time to look at who wins out. But ultimately, we want to be the Android of smartphone. Whoever makes smartphone, we don't care. We want to be that operating system and the infrastructure behind it.
If you have to pick one winner, who do you think has the best chance of winning AR?
Yeah, the question for the people who couldn't hear was, if you had to pick one winner, who do you think has the best chance of winning AR?
It's so hard to say. I think
The top two.
Apple and Microsoft, just because they've won the computer game before, the computer battlefield before. Hopefully that'll be the next computer they can win at.
So Apple and
Microsoft.
in that order?
No, not in a particular order.
All right, thanks, Jinping.
Thank you.